Let's practice a little bit more with division. We've got 3r to the fourth minus 8r cubed. Notice there's no r squared term, so that's where I'm going to put a placeholder, 0r squared plus r plus 20, all divided by r plus 2. So use that first step and put in that placeholder. Now I'm going to focus on the first. 3r to the fourth divided by r is 3r cubed. Now I'm going to multiply 3r cubed by the divisor, and I get 3r to the fourth plus 6r cubed. Now is when I'm going to subtract, which means I need to change my signs. I'm going to use another color to do that. And because I changed my signs, I can simply add negative 14r cubed plus 0r squared. Carry that down. Now I repeat my steps. Focus on the first. Negative 14r cubed divided by r is negative 14r squared. And multiply my quotient by my divisor, and I get negative 14r cubed minus 28r squared. Change my signs. Add up. Carry down. And I start over again. Focus on the first. 28r squared divided by r is 28r. I'm going to multiply and I get 28r squared plus 56r. Going to change my signs. And I get negative 55r plus 20. Focus on the first, negative 55. Multiply that out and get negative 55r minus 110. Change my signs. And my remainder is 130. So I have a remainder of 130. Or I could write it as 130 over r plus 2. I just wanted to show you both ways that it could be written like this, or on the previous page when we did the remainder over the divisor. Okay, so here's my answer. Let's do the next example. Got 5x cubed minus 18x squared minus 37x plus 0. I need that constant, so that's my placeholder there, divided by x minus 5. Focus on the first. Divide. Now I multiply. And then when I go to subtract, I change my signs. These cancel, and I'm left with 7x squared minus 37x. Focus on the first again. 7x squared divided by x is 7x. Multiply, I get 7x squared minus 35x. When I subtract, I change my signs. Negative 2x plus 0. Focus on the first. Negative 2x divided by x is negative 2. And we get negative 2x plus 10. Need to change my signs. This becomes plus. This becomes minus. And I'm left with negative 10. So my remainder is negative 10. That would have been very tempting. It actually was very tempting for me to just say 10 was my remainder. But I have to remember that I'm subtracting. That's why I always change these signs and then add up. And of course, you can check your answer. Take this and multiply it by r plus 2, and then add 130. Or take this one, multiply by x by minus 5, and add negative 10. Let's check this one. Let's just make sure. We have x minus 5 times 5x squared plus 7x minus 2. And then I'll have to add that negative 10, my remainder. When I distribute the x, I get 5x cubed plus 7x squared minus 2x. Then I distribute the negative 5, negative 25x squared minus 35x plus 10. And then I have a minus 10. When I add all that together, that gives me 0, which is what I had. Negative 37x. I have negative 18x squared and positive 5x cubed. So it checked out. All right. The next example says, find the product at 5. And I think what they're meaning here, or they're saying P is your original right here, because that's not your product, I'm sorry, P of x. Find P at 5. In other words, put 5 in for x, which would be 5 times 5 cubed. So we're letting x equal 5. That's what we're doing. Sorry. 5 times 5 cubed minus 18 times 5 squared minus 37 times 5. So I'm going to go ahead and I'm going to use my calculator to do this. And I've got 5 times 5, oops, 5 times 5 to the third minus 18 times 5 squared minus 37 times 5. And I get negative 10. Huh. I put a 5 in for x and I got negative 10. And look at what my remainder is. I would like to come up here to number 4. And I'm going to ask us, we'll call this number 7. Let r equal negative 2. And let's see what happens. And we're putting negative 2 into the original function. 3 times negative 2 to the 4th minus 8 times negative 2 cubed plus negative 2 plus 20. All I've done is put negative 2 into the original function. Okay? So we have 3 times negative 2 to the 4th minus 8 times negative 2 to the 3rd plus negative 2 plus 20. And I got 130. And look at that. This brings me to my remainder theorem. If P of x is divided by x minus c, then P at c, in other words, put c into the original, you will get the remainder. Well, this is a great tool because what this means that what we can do is we can check and see if we got the right answer without having to maybe do all of this. Now this only works if it's divided by x minus c, not 2x or x squared. It has to just be x minus c, and you just put c in. That's why r plus 2, we put in a negative 2. It's kind of like take the 0 of the divisor. Up here we would divide it by x minus 5, so we put in a 5. We divide by r plus 2, we put a negative 2 in. Why does this make sense? Well, not that you really have to know this part, but p of x is equal to the quotient of x times x minus c plus the remainder. Well, if you put a c into it, we have q at c times c minus c plus the remainder at c. Well, c minus c is 0, so this just cancels out, which is why it ends up equaling whatever the remainder is. Sorry, keep scooting my paper down. Because this c minus c will become 0, this all just becomes 0. If you want to write that down, that might make it make more sense. Q of c times 0 plus r of c. And then so you just get p of x equals 0 plus the remainder. So that's why they're equal. So let's look at number 7. Let's try using this remainder theorem. Because all I'm asking for is the remainder. If I'm asking for the whole quotient, you're going to have to still use the polynomial division. But if all I want to know is what is the remainder when I'm dividing by x minus 3, you would let x equal 3 in the original function. So I'm going to have 3 cubed minus 4 times 3 plus 1. You're going to put that into your calculator. 3 to the third minus 4 times 3 plus 1, and I get 16. So if I was asked to divide this by x minus 3 and I got a remainder that wasn't 16, I know I need to go back and check my work. So look at number 8. What's the remainder when we're dividing by x plus 6? So let x equal negative 6. And that is a 0.5, by the way. So in the original, okay, so we get 2 times negative 6 squared plus 0.5 times negative 6 minus 7. I'll put that into my calculator here. 2 times negative 6 squared plus 0.5 times negative 6 minus 7, and I get 62.